Okay, guys. As I said, I did make a mistake. I realized there's something I haven't included in the workbook. So we're going off book today. So the good news is what we're doing isn't necessarily like it's not a lot of notes. So if you want to write it down on one of those cards, it's probably not a bad idea, actually. Cool. Writing down one of those cards isn't probably a bad idea. I'm also going to show you. So I'm going to show you two things today. The first way, this is why it works. The second way is the easy way to remember rather than going through why it works each time. So both of those, just let this catch up. There we go. Okay. So if you're doing it in your book, guys, our title for today is exact values. And I'm going to explain some things that seem real weird to start with, probably, but they'll make sense. They'll make sense as we go through. The whiteboard thing. Oh, it's not showing. Thanks for letting me know. I'm joking. Yeah. So we'll go to that probably tomorrow. We'll just do a whole big lot of revision around the topics we've been doing around Trig and have a chance to just recap our knowledge. Next week we'll look at that, and that's only like one lesson or so. After that, we'll do the next topic. Okay. You guys can see that now. It's still recording. Excellent. Exact values. So, guys, I want you to imagine a triangle. Might be a little bit hard to imagine, but this is what they look like. Now, I'm going to tell you it's an equilateral triangle with a side of 2, 2, and 2. That tracking? Yep. If it's an equilateral triangle, what do the angles have to be? Equal? So what are three equal angles in a triangle have to be? 90 plus 90 plus 90 equals 270. 60. 60 degrees. 60 degrees. 60 degrees. Now, we've been learning about trig ratios. So now I yelled at Cody earlier in the term for he said trig was to do with triangles, and I told him he was wrong. Turns out only a little bit, because we are going to look at trig ratios to do with a triangle now. To use our sine cos tan, what kind of triangle does it have to be? Right angle. Is that one right angle? But what if I do this? Have I just split it into two right angle triangles? Yep. There and there. And if I've split that in half, would you agree that that's 30 degrees there and 30 degrees there? Yep. Okay. I'm just going to... We don't need both of those triangles, because can you see those two triangles are identical? By the way, if I look at just the left-hand triangle, how long is the bottom of just the left-hand bit? 1. So let's just redraw that triangle as is. We've got a 30-degree angle up there. We've got a 60-degree angle there. The hypotenuse is 2, and the base is 1. Are you all agreeing with me those facts are correct? Yep. Does anyone have a thought? How might I find x? Going back to year 9 here. Yeah, Pythagoras. A squared equals b squared plus c squared. That is the right way. Or some people write it as c squared equals a squared plus b squared. Doesn't really make much of a difference. Same thing. Okay, so guys, Pythagoras to solve for x. In this triangle, is it correct to say x squared equals 1 squared plus 2 squared? What do you think, Elizabeth?
Isn't C squared the same? A squared
Yeah. That was a trick question. This triangle would be, because it's always hypotenuse squared equals the other two added together. So this triangle here, we could say that 2 squared equals x squared plus 1 squared. Yep. Do we feel all right with that idea? Yep. I'll just rearrange that to get x by itself. Guys, there we go. I've just squared those two numbers that we can square. 2 squared is 4. 1 squared is 1. I'm just going to minus 1 from both sides. We happy with that? X squared equals 3. And we don't want x. We don't want x squared, sorry. We want x. So just square root both sides.
1.73.
Wrong. You're not wrong. But we don't like to use decimals if we don't have to. So we're actually just going to leave that as square root 3. We don't need to worry about it past that. That's our answer. X is the square root of 3. So I'm just going to add that to my square root of 3. Okay. Now, you guys are probably looking at that and being like, what the hell does this have to do with sine waves? Yeah. I don't know. I've just been wasting time. No, I'm kidding. This is actually relevant. We're going to use this triangle here to create what we call exact values of trig ratios. Guys, if I asked you what sine 30 is, what's the ratio for sine 30? Like, what does sine 30, what two sides does it compare in a triangle? O and H, opposite and hypotenuse. If this is my 30-degree angle here, what's opposite to it? 1. What's the hypotenuse? Sine 30 is equal to a half. Would it matter if my triangle was bigger or smaller? Will the value of sine 30 change? That is true for every single triangle ever. Now, in regards to what I just said before, where this is relevant, that means that at 30 degrees, sine is exactly half the way up to its maximum amplitude. If that makes sense. So if your maximum amplitude is 1, so if it's just a regular sine theta wave, at 30 degrees, or pi on 6 radians, that is when your function is at 0.5. So that is the link, basically, to the sine wave stuff. Did what I say just really confuse you? Okay, I'll explain a bit more. You weren't listening? Okay, let me just draw this, guys. We've got 1 up here, 0, negative 1. Pi. Well, that is not even at all. We're going to be besties. Okay, so we happy that that's the line of y equals sine theta from the other day. Now I happen to know that a half happens at what angle, at what turn of sine? 30 degrees, which in radians would be what? Pi on 6. So where the function is at exactly 0.5 high, is it pi on 6? That's all that means. I hope that was a little bit clearer. The next one we're going to look at is a little bit less clear. If I look at sine of 60 now, Sine of 60 is opposite over hypotenuse once again, right? So sine of 60 equals O over H. So this is our angle in the bottom left corner. What's the opposite in this case? Which is root 3. So the exact value of sine 30, what am I doing? Because of this, where we use Pythagoras to figure out what the value of x had to be. And the hypotenuse is still 2. Over 2. Okay. So any time, now the half makes a lot more sense to our heads because we think in halves really well. We don't think in root 3s very well, and you don't really need to. But basically all this means is anytime you're at an angle of 60 degrees, sine is equal to the square root of 3 over 2. If you put sine 60 into your calculator, you'll get some number. If you put the square root of 3 divided by 2 into your calculator, you get that exact same number. Those two things are equal to one another. Sine 60, root 3 on 2, same deal. Let's look at cos now. Cos of 30. Jeez, I'm losing it. To graph these. Cos 30, guys. If I'm looking at my 30-degree line, my 30-degree angle, cos is adjacent over hypotenuse, right? Adjacent, root 3 on 2. Root 3, hypotenuse 2. A over H equals root 3 on 2. Cos 30 and sine 60 are the exact same value. If you remember back to our unit circle, you know how cos and sine, they just do this exact same values, just in different orders and in different, like either positive or negative. And that's what we're getting at here. Does anyone want to guess just based on that what cos 60 is going to be? No, because cos 30 is square root of 3 on 2. 1/2. It would be exactly 1/2. Cos 60 is just A over H once more. And if we look at 60 degrees, the adjacent side is 1. The hypotenuse is 2. 1/2. Okay. Aside from 30 and 60, is there another common angle that we use when we're talking about our unit circle or trig ratios? Sorry. 90. We'll get to 90. Not quite yet, though. 45. We do 45. So. Is there a way we can use 45 to figure out an exact value of this stuff here? Like, is there any 45 degrees in that triangle we can use? No. So we're going to have to draw a new triangle. By the way, guys, can anyone get, like, we could do the same maths with a bigger triangle and we get the same answers. This is just the smallest triangle because it's got the smallest side is 1. It's the smallest triangle we have that uses mostly whole numbers. You're never going to get whole numbers for all of them because that third side is root 3. So this is just as small as we can go. So I'll leave that up there because I can see some people are still copying it down. But we want to look at a 45-degree angle triangle. Now, this one's actually a little bit easier, guys. Does anyone know what's special about a 45-degree angle triangle? Well, I suppose the fact that 90, 45, 45 is the only way the angles can be up. What do you call a triangle with two angles the same? It starts with I. Isosceles. What's the other thing that's the same in isosceles? Has two angles the same? What else is the same? Two sides. So once again, we're just going to make the side that's the same as small as we can. So the smallest simple number is 1. So I'm going to make this side 1 long and that side 1 long. Is that all good, guys? Yep. And we're just going to figure out this value. I'm going to call it y. How are we going to figure out y, guys? It starts with P and rhymes with Pythagoras. Pythagoras. In this case, it's a little bit easier because we're trying to find the hypotenuse. So it'll be easy to solve. So for this one, root 2 will be the answer, yeah. Y squared equals 1 squared plus 1 squared. Y squared equals 1 plus 1. Y squared equals 2. Y equals the square root of 2. Square root of 2.
Dang.
Which bit?
So, like, what are we trying to do? Find the other half of it.
I'm trying to make a link between angles and trig ratios and what they're equal to. So I'm going back to year 9 where we learnt about, sine of 30 is, and we thought about it in terms of triangles. And because sine of 30 is the same value no matter how big the triangle is, that means sine of 30 is true for every single triangle. We'll have the same value, sine of 30.
So why do we start with y squared? Y squared.
That's just Pythagoras. Hypotenuse squared equals the other two sides squared and added together. That's just Pythagoras' theorem. So that's the smallest 45-degree angle triangle we can. What would then sine of 45 be?
Either O over H.
Sine is O over H, yep. So what's the opposite in this case? 1. What's the hypotenuse? Root 2. Let's do cos. Now this is going to blow your minds. It's going to be exactly the same. Because can you see that triangle is like just symmetrical? Doesn't matter which angle you're looking at, the opposite and the adjacent will be the same. So cos 45 is also 1 over root 2. Now, I've been using angles here because I've been using degrees rather because we've been talking about triangles. But we know that there is a direct link between degrees and radians. So let's just rewrite this into a table using radians instead. So, we've got sine and cos. What's the smallest angle we're going to look at in terms of our unit circle? It's the smallest angle we're going to look at. 30? We don't really look at 15. So we generally only go to 30. But it's also a little bit of trick because the smallest would be 0, right? Sine of 0 radians. Does sine measure our x or our y in the unit circle? Height or length? Just the height. So the y. At 0 degrees, what's the height on the Cartesian plane? 0. So sine of 0 equals 0. Like we said, the next increment up would be 30 degrees, which is pi on 6. 30 degrees. Might take a bit more space than I thought. So sine of pi on 6. What did we say sine of pi on 3 was? Or sine of 30 was? According to our triangle. So sine of pi on 6 is equal to a half. Okay. Up from 30 degrees, what will be the next major increment we look at? 45. And then 60. So what's 45 as radians? Pi on 4. Sine of pi on 4. And what did we say that sine of 45 was? 1 on root 2. Just a quick note, guys. 1 on root 2, some people are pedantic about this. They don't like having an irrational number on the bottom of the fraction. So some people prefer to write it the square root of 2 over 2. Those two numbers are the same. Some people write it 1 on root 2. Some people write it root 2 on 2. They mean the same thing. If you see in the textbook, root 2 on 2 means the same thing. I don't care which one you use. They're both correct. I'm not fussed. Okay, and then the next one will be 60, like we said, which is pi on 3, which is 60 degrees. What would sine of 60 be, or sine of pi on 3? Now, I'm just going to point something out. I'm going to rewrite this sine one as the root 2 on 2. Can you see that they're all divided by 2? Then it goes 1, root 2, root 3. Is it a definite pattern there? What's the next major angle after 90? Which is just pi on 2. Pi on 2, which is 90 degrees.
Root 4.
Root 4 on 2. What's the square root of 4? 2. 2 over 2, which is 1. So sine of 90 is 1. But yeah, your thinking is right there. Sine pi on 2 equals just 1. Like I just said to Lachlan, if you follow the pattern, that would be root 4 on 2. Square root of 4 is 2. 2 on 2. 2 divided by 2 is 1, which is where we get the 1 from. Okay. Does anyone want to guess what cos is going to be? Like, will cos have different values than sine? Exact same, not in the same spots, but you are going to see 0, a half, root 2 on 2, root 3 on 2, and 1 again. Yeah, they're just going to be swapped around. So instead of starting at 0, what are we going to start at? 1. And instead of finishing at 1, we're going to finish at 0. So cos of 0 is 1. Cos of 30 degrees, or pi on 6 radians, is root 3 on 2. Cos of pi on 4 is root 2 on 2. Because remember, at 45 degrees, they have the exact same answer, root 2 on 2 or 1 on root 2, whichever you want to use. At 60 degrees, cos of pi on 3 is 1/2. Cos of, that should be pi on 2. Pi on 2 is 0. Okay. Does the logic behind that make a little bit of sense, guys? I think I've broken Jesselyn's brain. Either that or it's so easy you're bored by it. Okay. I'm not going to touch on tan here, guys. We're not going to worry about tan. If you ever want to know tan is just whatever your cos value is divided by whatever your sine value is. So tan is just x over y. We don't need to know that for now, so just don't worry about it. There is a way to solve tan using the same system. Okay. I have shown you how to calculate these manually. You're never going to have to calculate them manually ever again in your life. And I'll show you what. I've got a video queued up for you. I might just pause the record this video. I'm just cutting off her forehead. Yeah. I'm not making money off these. Can you hear that?
Angles, but a different trick this time, rather than that table of values. Take either hand with your palm facing towards you and label your little finger at 0 degrees, your ring finger at 30, middle one is 6, and your thumb is 90 degrees. To make this work, you just need to remember to square root the number of fingers and divide by 2. So if we wanted sine 30, we'd bend down our 30-degree finger, and you just have your baby finger underneath. So sine 30 is square root 1 divided by 2, because there's only one finger underneath, which simplifies to a half. If we wanted sine 90 degrees, you'd bend down your 90-degree thumb, and so you have 4 fingers underneath. So sine 90 is square root of 4 divided by 2, which simplifies to 1. What would sine 60 be? Work out the answer and click here.
What would sine 60 be, guys? Square. No. 60 is this finger. Root 3 over 2.
And you get the top number?
The top number is just the square root of how many fingers are left underneath the one you bent down.
Always divided by 1.
Always divided by 2. Sorry? I will talk about that. We'll talk about that.
Very hard.
Did you get square root 3 divided by 2? Because we just count the fingers above instead of the ones below. So for cos 60, bend down your 60 finger and count the fingers above.
So that's the difference. For cos you count above, for sine you count below. That's the only difference.
So cos 60 is square root 1 divided by 2, which simplifies to a half. What would cos 90 be? Work out the answer and click here when you're ready to check.
Root 4 on 2.
Did you get 0 degrees? Bend down your...
Oh, yeah. No fingers. I was doing sine, my bad. Oh, no, sorry, I did 0, not 90.
Just one extra little twist. The same as for sine and cos. Bend down...
Okay, I don't care about tan. Tan sucks. Okay. Someone, and my brain's not working, so I forgot who said, what about if it's not between 0 and 90? Was that you, Alyssa? Yeah. Okay. Let's look. Let me move my screen. Sorry? So remember back to when we learned about cast, and we know that there's everywhere where an angle is, there's a matching angle in quadrant 1. So basically what we do is we figure out what angle we have, what the matching angle in quadrant 1 is, and whether it will be the positive or negative version. So you look like you just had an epiphany there. So, like, you're just like, oh, it makes sense. Okay, cool. So guys, if I said to you, let's do a few easy ones. So find the exact value of...
So can I use the word?
Sure.
Yeet. Don't say that again, please.
Yote. YOLO. Lit fam, hit it with a dab. Let me say that into the mic. Lit fam. Okay. Let's...
It's my night.
They're gonna be like, he sounds like the best. Okay. It's a secret plot to get people to listen to my videos, get my subscriber count up. Okay, so let's find the exact value of, let's say 2 pi on 3. Let's find the exact value of, let's start with a sine. Sine 2 pi on 3. I'm going to, the way I like to do these guys is I just draw myself a little set of axes. Can anyone tell me which quadrant would sine 2 pi on 3 occur? What is sine 2 pi on 3 as an angle, as a degrees angle? 120. So 120 quadrant 1, 2, 3, or 4. No. So quadrant 1 is 0 to 90. Quadrant 2 is 90 to 180. So 120 is in here. So this is 2 pi on 3. Where would the matching angle in quadrant 1 be? In 60 degrees or pi on 3? Can you explain why that is the matching one? Yeah. So is it correct to say that sine 2 pi on 3 is just going to have the exact same value as sine pi on 3? Where is sine positive? You're thinking in the right direction, but if I do my cast here, Cody, cos all sine tan. So sine's positive in 1 and 2. So they're going to have the same sign. The next one we'll do it will be a negative one though. So if I use my finger trick sine, do I go above or below? So 0, 30, 60. Sorry, that was 45. 60, 1, 2, 3. Root 3 on 2. Does that match our table where we figured everything out before? Sine pi on 3 is root 3 on 2? Yeah, that's it. Does that make sense to people? Ryland's a bit lost. That's all right. It's all right. This happens. I'll be honest, guys. The fact that half the class is saying, yeah, that actually makes sense means that you're doing better than the last 2 classes I've taught this to. A lot of students struggle so hard with this idea. So if you're not quite getting it yet, don't feel bad. Let's do another one. Why don't I do cos? Cast. So cos is the only thing positive in quadrant 4. All the trig values are positive in quadrant 1. Only sine is positive in 2, and only tan is positive in 3. Okay, so let's do cos of... Yeah, so that would be cos of 5 pi on 4. I'll just draw my little axes here, guys. Remember, how did I say to think about numbers like 5 pi on 4? You think about how far you're turning and how many times you turn that direction. So what's my angle of turn each time for this one? Pi on 4 or 45 degrees. And how many times am I turning pi on 4? 5 times. So let's do it. So pi on 4, I'm just splitting it up. I'm splitting it up into pi on 4s. Just from see, it's 5 pi on 4. It'll always be pi divided by the number is how big your turn is. Just is. I'm not sure I follow. If I said cos pi on 4, right? That'd be simple. You're just turning 45 degrees, pi on 4 degrees. Or pi on 4 radians. Yeah. Alrighty. So can you see that I've split my units or my Cartesian plane into 45 degree turns there? So I'm at 0, 1, 2, 3, 4, 5. So I'm down here. So this is 5 pi on 4. I'm down here in quadrant 3. So in quadrant 3, is cos positive or negative? It's negative. Only tan is positive in quadrant 3. Now, can you see that cos, remember, measures x, measures how far across you are? Cos of 5 pi on 4 is giving you that distance there. What would the equivalent turn in quadrant 1 be to 5 pi on 4? What would the equivalent turn in quadrant 1 be? So in quadrant 3, our angle is 5 pi on 4. What's the angle in quadrant 1 that matches up with that? Pi on 4, that's it. Because that would give us this distance here. Can you see that those distances are the same?
Where do you count from 5 pi on 4?
Give me a sec. Pi on 4. It's hard because I'm like trying to gesture on here and it doesn't show up very well. 0, 1, 2, 3, 4, 5. You always start here. Unless I said to you negative, if the angle is negative, you go the other way. Okay?
These are the rubber sets.
Yeah. So like if this correct.
So do you have the rubber rejiggy?
It's in the top of my laptop bag there. So using our cast rule, guys, we know, and even looking at the Cartesian plane, because I'm to the left of it, I'm in the negatives. For pi on 4, I'm in the positives. So cos pi on 4 is just going to be equal to the negative version of cos pi on 4. Does that make sense? Are we feeling that? We getting it? I'm taking that silence for yeah, we're all over this. Yeah. Do you get why I've said negative cos pi on 4 though? Because if I make cos pi on 4 negative, it's going to be the exact same as that. Because my original answer is negative, cos pi on 4 will be a positive number. So to make them the same, I have to force cos pi on 4 to be negative instead. So I have to manually put that negative in front of it.
Not if you did like pi on 3.
Well, we'll do a pi on 3 next. Yes, it is more annoying. Well, you could write it like negative cos pi on 4 is equal to cos pi on 4. Those two things are still the same. They just need to have opposite. You need to. Yeah. Okay, let me phrase it this way. That statement there is untrue. Cos 5 pi on 4 equals cos pi on 4. That is not true. Because we know that cos in quadrant 1 and cos in quadrant 4 are negative versions of each other. So to make this equal statement true, I need to add in a negative to rebalance that equation. And all I need to do then, cos pi on 4, 0, 30, 45, third finger, and we go, for cos, do we go above or below? Not that it matters for this one. We go above. 1, 2. Root 2 on 2. Negative root 2 on 2, sorry. Can't forget our negative. Do you mean as in top of the fraction in front? I always put it either in front or on the top. I wouldn't put it on the bottom. That's just weird, but that's just my personal preference. Doesn't matter where you put it. I'm conscious that I'm using up a lot of time explaining this, but I think it's important. I'll go through a couple more examples you might come across, and then I might actually give you guys 3 that I want you to have a go at. So I want you to find sine of 5 pi on 6. I want you to find cos of negative 2 pi on 3. And I want you to find sine 11 pi on 4. Can you have a go at finding those 3 for me? Lachlan, reckon you got these in the bag? Or do you want a hand? My advice, guys, like I said, draw your diagram first. Okay. Alright. So in this first one, 5 pi on 6. And sine or cosine?
So it's part 6 first one. What does the
I'm going to go through the first one over here, guys, just quickly. If you're a bit stuck, feel free to listen in. So, 5.6. How big is my term? I see where you got that. What I mean is, you know how in that other one say, oh, I'm doing five turns of pi on 4. So how many turns of, yeah, so let's just draw out. So that's 90 degrees. Do you need a bit higher? That's enough. So pi on 6, easiest way to split this into pi on 6, I find, is do pi on 3. I'm just gonna, can you see that I split that 180 degrees into 3? Split it to 6, just each of those half each of those sections. 1, 2, 3, 4, 5, 6. Sorry, Clarice?
6, 4, 3.
I'm not sure I understand.
Like the line is the 3 lines.
6, 4, 3.
section. It's 3 lines.
Oh, yeah. So if this was the regular one, we would normally have one at 30 degrees, 45, and then 60, which is pi on 6, pi on 4, pi on 3. Okay, so we're doing five turns, right? So 1, 2, 3, 4, 5. We're over here at 5, 6. So which would be the matching one? 6, that's right. 6. So we can say that that is equal to sine pi on 6. And using our finger trick, 0, 30, 45, 60, 90 would be the first one. So sine of pi on 6 is just root 1 over 2, which is just 1 over 2. That's all there is to these ones.
Alright, just go figure it out.
Yeah, the biggest hurdle for these ones is figuring out where you are and where the matching angle is.
Yeah.
Making sense?
Yeah. Already done.
Oh, you've already done that. Yeah, that makes sense. Yeah. Do you want to, if you've already done this, do you want to grab your textbook? The questions are on page 516. Just have a go at solving those questions. 516. Yo.
Yeah, same. Like we do this. And then how do we get to?
Where does it get pi on 40?
Yeah, so when you get
Okay, so remember up where we're drawing these triangles and we showed that sine of 45 is 1 on root 2 or root 2 on 2, whichever one you want to do. That is true for every value of sine 45 forever. That's where we got it from.
So that's generic.
That's for every single cos 45 ever. Okay.
Hold the second one, the cos.
Yep.
We were the opposite direction.
Yeah, you just go, instead of going that way, you'll start turning that way.
Yeah.
5. Let's say, I think it was 18, 518. So 0. Oh, so it's always the square root of the number of errors. How many fingers you get? Because it's what we got from.
Yeah, that would be because it gets visual.
So just put two.
There are no 550. Only 20. Yeah, 20.
516.
So, I don't say what 5.6.
How do you?
What angle 1.6?
5 on 6.
Oh, I mean,
70 degrees.
So, well, turning back to the. You see that over
What?
here, 5 pi on 6. And we're doing
180 divided by
sine is
5.
always
And then whatever number's up here is 5 of that. Could be pi on 6.
matching pi.
That's it.
So
Pi.
it's another 5 times.
Or cos, because it would also be the math.
Why do you get 5?
Yeah, you were. Which one? You said the.
Where's the
No, we'll always match that. Oh, yeah, it's what they are.
Yeah.
But we'll still match it back to it. But so, for instance, if we were trying to like this one here. So this is 7.0.
And then we'll just go not 90.
You see that right
Just
there,
up there.
it's just a negative version of that. Okay. So that would take me. So those two would be equal. But now
What you do, what you
does
got,
about
so you write.
we didn't get everything back for it. So that's what we have to.
How do you think that was happening? How do you write?
We'll just figure out what it would be important and then either make.
So it's 180 divided by 2.
And also the negative. Or
But how
which one?
All
So you just wrote so you
I don't get this.
And then you plug
instead of going in positive direction.
like 5.
Oh, it is so when you go back around here, it would just be
Yeah.
oh I'm pretty sorry.
What?
Yeah, so you figure it out.
So we're just finding out what these.
Sorry.
Wait. Just finding out what it's yeah.
In this case here.
That's right.
So why don't you just do question on board?
3
No, we just do
it would be
Oh, we
cos would be at the is in quadrant 3 it should be negative.
What is 190 divided by? For real? Yeah, you say you do that.
I'm about to, yeah.
When you go.
Do you want to go through these answers first and then you can go? Or do you really need to go? Just grab the card there. Okay, guys, I'm going to go through 2 and 3 on the board. Eyes up here, please. Even if you've done these ones, guys, I want you to pay attention. Okay, still waiting. For question 2, guys, we've got cos negative 2 pi on 3. So straight away, the first thing I want you to recognize is that we're going around in pi on 3s, and I'm going to go negative 2 of them. So instead of going forward 2, I'm going to go backwards 2. Sorry? Yeah, I get you. I'll demonstrate it correctly on the board, which is in the right orientation. So this is my Cartesian plane. I want to count around it in pi on 3s. Pi is 180 degrees, so I'm splitting 180 degrees into 3 sections. So I'll do it in a different color. So I'm starting here at 0. That didn't work. I'm starting here at 0. I'll use a thicker pen. 0. 1, 2, 3. So I've split my thing into 3. And then yeah. I'm only scribbling that so it's very clear what's the axis and what's the pi on 3 lines. I need to go -2. So I'm still going to start here at 0, but this would then be -1 pi on 3, and this would be -2 pi on 3. Cool? If you did it the other way, you might have the wrong sign, but otherwise you should have the right answer. Because we're looking at cos, and we're in quadrant 3. Is cos positive or negative in quadrant 3? Negative. So it's going to have a matching value in quadrant 1, but it's just going to be the negative version of it. Okay? Now, cos, does it find my x direction or my y direction? X. So I'm trying to find... You see that's the triangle that's sort of being made there? And I want to find the x part there. Now, how many different pi on 3 lines are there in quadrant 1? Just one.
0.
Oh, 0 and 1, yeah, I guess. But we're essentially going to want to find... we just want to find pi on 3. Can you see that -2 pi on 3 is going to align with pi on 3 in quadrant 1? You always go to quadrant 1. Every single time, just because, like you said, we know the answers for 0, 30, 45, 60, and 90. So if we always convert it back to the similar one to those numbers, we always know our answer. So for those ones, guys, -2 pi on 3 matches with pi on 3. Will it be the same or the negative version? So different signs. So we just need to swap the signs. So we can say that cos -2 pi on 3 is the same thing as negative cos pi on 3. Just visually, they're the same thing, but just negative version. Which means my answer will be cos pi on 3 is 60 degrees, 0, 30, 45, 60. And for cos, we go above. Yes? 1 on 2. -1/2 is my answer. Make sense, guys? Who got that one? Didn't get it? What did you get? What?
I figured it out. I got to 4 pi on 3, and I was like, no, I got that, and I just didn't think to get the first way.
I see. Okay. Oh, that's probably worth pointing out, guys. See how I've labeled this line 2 pi on 3? If I went around this way instead, 1, 2, 3, that's the same thing as 4 pi on 3 as well. So I'm just going to put in brackets next to it 4 pi on 3. So that's the other thing you could do. You could have, in your rule, said, okay, well, -2 pi on 3, and figured out that's the same thing as 4 pi on 3, and 4 pi on 3 is the same thing as -pi on 3, and gone from there. Okay, last one, guys. Sine. A half. So do you get that where we got the negative cos pi on 3 from? Yep. So you can either go back to your table, or you can do your hand thing. Sorry? Oh, you went down. I get you. So this one, guys, what are we counting in? Pi on 4. I love that we're in math methods, and this essentially becomes a counting problem. So pi on 4, I need to split the top half into 4, the bottom half into 4. Top half is split into 4. 1, 2, 3, 4. Bottom half is split into 4. 1, 2, 3, 4. Cool? Cool? We want to do 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 pi on 4. It's obviously going to have to match it with 1 pi on 4 back in quadrant 1. And we're doing sine, so we're doing the height. So that height obviously matches that height, if I drew it correctly, which I didn't. But use your imagination that I drew that better. Thank you. So I know sine. In quadrant 1 and 2, do they have the same value or opposite values in terms of sign? They're both positive. So sine 11 pi on 4 is just the same thing as sine pi on 4, which is, yeah, so if you count, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
Yeah.
Does it matter that we've done an extra circuit of the circle? No, it doesn't. Couldn't matter less. The values are all the same. Okay, and sine pi on 4, 0, 30, 45. Root 2 on 2. I just have this image now of me walking around the school and students just going, root 2 on 2, gang!
What's happening? Not the head of government.
Okay. In my defense, I spent all of yesterday at the bloody F1 in schools comp. I got like 3 hours of sleep. I'm buggered. Just had a bloody year 8 maths class. That wasn't fun. Anyway, guys,